Hello students. In the previous videos, we discussed about unit cell and the close packing structures. Let us discuss relation between the unit cell and the radius of the sphere. Here, the particles are considered to be sphere. So radius of the sphere means radius of the particles. As we have discussed already, unit cell are of three types, that is simple cubic unit cell, body centered unit cell and face centered unit cell. The number of particles in these are 1, 2 and 4 respectively, which we have calculated in the previous some videos. Let us find out the relation between the edge length and the radius of the sphere for simple cubic unit cell. Simple cubic unit cell, as we have already discussed, particles are present only at the corners of a cube. Let A is the edge length of the unit cell. A is the edge length. In reality, these particles are very closely packed. That means these particles, let I am considering these two particles, these are actually touching each other, which is shown in this figure. The particles are touching each other. Let I am making a line between the center of this sphere. So these are touching each other. So that means the edge length of the unit cell is the distance between the centers of two adjacent spheres. So let R is the radius of the sphere. So this is the radius of the sphere. This is the radius of the sphere. So from this it is clear that A is equal to 2R. Since the particles are touching each other, that means the particles on the edges are touching each other. Therefore, we can say that A is equal to 2R. So, we can find the relation here, that is R is equal to A by 2. That means the radius of the particle is equal to half of the edge length in a simple cubic unit cell. Let us find out the relation for the body-centered cubic unit cell. In body-centered cubic unit cell, particles are not only present at the corners, but one particle is present at the center. This is the center particle. That is, the whole particle is present in the body of the cube. So let us derive a relation here. Consider a right triangle, that is ABC. It is highlighted in the first figure, that is A, this is B and this is C. In the right triangle ABC, AB is the edge length, that means this is the edge length, and BC is also the edge length. Let the edge length is taken as A and the radius of the sphere is taken as R. So, according to Pythagoras theorem, AC square is equal to AB square plus BC square. So, from the figure, AB is equal to A, BC is equal to A. So, AC square is equal to A square plus A square, that is equal to 2A square. Now, let us take another right triangle, that is ACD. ACD. When apply the Pythagoras theorem, we'll get AD square is equal to AC square plus CD square. As CD is the edge length, so we'll take CD is equal to A and Here AC, we have already find out the AC square value. So substitute here. So we'll be getting AD square is equal to 2A square plus A square. When we solve this one, we'll get AD is equal to root 3A. But AD is also is equal to 4R. Look at how it is equal to 4R. This is AD. So I am making this AD here. This is A, this is D. So look at the figure. There are 3 spheres on this line AD. That is 1. This is the second sphere. This is the third. All spheres of same size. And so AD is equal to, that is R, 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 R. That means it is a sum of 4 radius. So we can say that AD is equal to 4R. So now substitute AD is equal to 4R. Equate with the AD is equal to root 3A and AD is equal to 4R. So when you solve this one, we will be getting 4R is equal to root 3A, then R is equal to root 3 by 4A. So this relation is the relation between the R and A for the BCC is equal to R is equal to root 3 by 4A. Now let us discuss the relation for face-centered unit cell. In face-centered unit cell, particles are not only present at the corners but also center of each face. Each face, here 6 faces are there. So on each faces at the center, one particles are there. Let the edge length of the unit cell is taken as A. The radius of the sphere is taken as R. Let us take a right triangle ABC, which is highlighted in the figure. A, this is B, and this is C. Apply the Pythagoras theorem. AC square is equal to AB square plus BC square. Here AB and BC are the edge length, that is A. So AB can be taken as A and BC can be taken as A. So we'll get AC square is equal to A square plus A square. So from this AC is equal to root 2A. But AC is equal to 4R. How it is 4R? I am making AC once again here. A and C. Look at the figure. There are 3 spheres on this line. 3 spheres and they are touching each other. So these are the 3 spheres. So this is the radius of this and this is the whole diameter, that is 2R, and this is R. So total AC length is equal to 4R. Now this is AC, this is AC. So we'll be equating these two ACs. So we'll be getting 4R is equal to root 2A. So when we solve this one, we'll be getting R here. R is equal to root 2 by 4 into A. So this is the relation between the radius and the edge length in FCC. So in this way, we have find out the relation between the radius of the sphere and the edge length of the unit cell. So this is all about the relation between the edge length and the radius of the sphere. Here sphere is actually the particles. Now the details of the unit cell will be discussed in the next video. Thank you everyone.